Good afternoon, everyone, and welcome to my presentation. First of all, let me thank you all for coming here. Let me start by saying a few words about my own background. May I introduce myself? My name is Dr. Moe Thanda Kyi from Myanmar Aerospace Engineering University. As you can see on the screen, my topic is Apparatus and Analytical Technique for Biomass and Materials. My talk is particularly relevant to those of thermography analysis for biomass and materials. This study focuses on the thermography technology. This presentation structure as follows: abstract to conclusion. First of all, I would like to see you an overall construction of thermography analyzer TGA image and parts of main body. I have calculated the concept design and construction of the device to thermography measurements and the result of tests carried out on wood pellets. I would like to present abstract. The result paper presents the concept, design, and construction of the device to the thermography measurements and the result of tests carried out on wood pellets. The purpose of this paper is to study the characteristic and thermal degradation behavior of wood pellets for biofuel production via gasification technology. The elemental properties of the feedstock were characterized by an elemental analyzer thermal properties were investigated using thermography analyzer TGA. The gasification process were being carried out at room temperature up to 900 degrees Celsius in the presence of nitrogen and air as gasification agents. Gas flow at 500 ml per minute. The investigated parameters are particle size and heating rate. Particle size used in the range of 425 to 500 micrometer. Heating rate applied 10 degrees Celsius per minute. Sample weights were varied from 0.5 to 1 gram. Stainless steel tray was used for the test. The paper contained the result of the test carried out on wood pellets in the form of thermography caps. These studies are conducted by looking at opportunities to improve the energy efficiency of the gasification process of biomass. I would like to introduce thermography analysis TGA. TGA is an essential laboratory tool used for material characterization. TGA used in various environmental applications, food, pharmaceutical, and petrochemical applications, and so on. TGA is a technique in which upon heating a material, it weighs increase or decrease. This study focuses on the thermography technology. Figure 1 shows thermography process flow diagram. I would like to present objective as follows: to calculate the design of thermography to construct thermography experimental setup, to make experiment with thermography to perform a thermography analysis of fuel for laboratory and classroom purpose, to exchange knowledge and experience in thermography analysis of teachers, students, and others. The goal of the project is to improve technology demonstration, technology transfer, research, collaboration, and innovative technologies in university and industrial sectors. I would like to present purpose of research, a method of thermography analysis and concept design and execution of the instrument to thermography measurements. These studies are conducted by looking at opportunities to improve the energy efficiency of the gasification process of biomass. Then we will consider experimental apparatus diagram in figure 2. I will focus on construction of experimental setup. Then I will go on to highlight what you can see as the overall construction and parts of apparatus such as reactor, sample tray, and thermocouple, and so on. I construct experimental setup, and you can see parts of apparatus such as temperature controller, gas flow system, and so on. This is part of main body. This is desiccator. In desiccator, which contain semi-microbalance, logia, small PC. PC can record mass change by software. Logia can record sample temperature by using thermocouple. This is heater. Heater can use up to 10,000 degrees Celsius by using K-type thermocouple heater to temperature controller. This is temperature controller. To control temperature, the PID type controller was used. This is gas flow system. Flow meter with precision needle bulb. Nitrogen is used to display oxygen from the heating chamber while simulating the process. Sample preparation has significant effect in obtaining good data. 10 to 20 mg of sample is preferred in most applications. The sample has volatile. 50 to 100 mg of sample is considered adequate. We use particle size 4 to 5 micrometer. I would like to present experimental setup and procedure. The experiment will conduct using a reactor in a batch process at atmospheric pressure. Height and inside diameter of the reactor were 400 and 52.7 mm respectively. Nitrogen flow rate is 500 ml per minute. Wood pellet sample between 0.5 and 1 gram were gasified to a maximum temperature of 900 degrees Celsius. The sample heated to 110 degrees Celsius and kept at that temperature for 30 minutes to remove any moisture. After that, the sample were heated at 10 degrees Celsius per minute until 900 degrees Celsius. The temperature is held room temperature to 107 degrees Celsius for 10 minutes, then kept 107 degrees Celsius for 1 hour, and then 107 degrees Celsius to 900 degrees Celsius for 1 hour and 20 minutes, then kept 900 degrees Celsius for 7 minutes. Then reduced to 815 degrees Celsius. Air is introduced at 900 degrees Celsius after 7 minutes until the oxidation reaction is complete and no further weight loss is observed. The experiment was repeated for each week. I would like to address characterization or ultimate and approximate analysis of wood pellet. Wood pellet size used in the range of 425 to 500 micrometer. I would like to discuss our project result. The result of the blend test and sample test are shown in figure. I would like to present blend test. In blend test without sample, air is poured at 500 ml per minute and the temperature is right up to 10,000 degrees Celsius at heating rate of 10 degrees Celsius per minute. By this blend test, the general condition of the apparatus can be known. The result of the test shown in figure. I would like to present test result. From the result obtained, sample weight 1 gram is better than 0.5 gram because of experimental apparatus by semi-micro balance. The problem observed related to the stability of the process. The stable operation of the process were very thin thermocouple with sample tray, semi-micro balance and dodger. I would just like to conclude, constructed apparatus allow to study thermal decomposition of solid fuels and obtain thermogravimetric curves are similar to those that can be performed on commercial thermobalance. The advantages of the device is definitely lower price than of commercial solution. TGA applied in various areas such as polymer-based manufacturing, pharmaceutical manufacturing, food manufacturing, metal manufacturing, petrochemical manufacturing, environmental application, plastic manufacturing, polymer manufacturing, and so on. I would just like to finish with the words of sustainability and future plan. It meets the needs of the laboratory and industry and lasts a long time is a sustainable product. It can be repaired, that is, can be disassembled and its part can be replaced. Recommendation for future research. To test carried out on types of solid fuel in the form of a thermogravimetric curves to determine the level of the bioreactive process temperature and degree of combustion of solid fuel into fuel gas. Thank you very much for your kind attention. If you have any question, I am happy to answer them. Thank you very much.